Hello everyone, I am Rahul Singh. I am currently doing research along with my team in the field of education at Poorvi. Our mission is to open the biggest educational research center in Bangalore with a clear goal to support and empower educational institutions in creating innovative, creative and effective study material for their students. Over the year, we have already helped many schools by providing research-based academic support and modern learning resources. Today is another step in that journey. One of my junior team member, Poorvi, is going to present the topic metal and non-metal in very innovative and engaging way. So without further delay, over to you, Poorvi.
Thank you. Hello everyone! A small warning before we begin. If you thought that metals and non-metals chapter was just about iron rusting, gold shining and you imagining a long chart, maybe even an app, but not today. I am Poorvi from Nexus QI and I am here to prove that chemistry doesn't have to be boring. I am introducing something creative, colorful and unforgettable. The butterfly method. Now why a butterfly? Because just like chemistry, a butterfly is balanced, beautiful and full of surprises. So instead of memorizing endless points, you'll be picturing a butterfly every time you think of chemistry. And trust me, once you learn metal and non-metal this way, it's like giving chemistry wings and we are the pilots. So instead of memorizing endless points, you'll be picturing a butterfly every time you think of chemistry. And trust me, once you learn metal and non-metal this way, you'll never forget them. It's like giving chemistry wings and we are the pilots. So tighten your seatbelts, activate your neurons because this chapter is about to become the easiest, funniest and most unforgettable chapter of class 10 science. Let's begin. Now starting on with the first section of metal and non-metal, physical properties. Imagine metals and non-metals as chemistry classmates in a high school. Metals are the gym bros and non-metals are the drama queens, fragile, colorful and unpredictable. And then there are the class clowns, the exceptional ones. They always break rules. Starting off with first, physical state. Metals, they are solid squared. Iron, copper, gold, they are always rock solid. But mercury is a rebel liquid metal and gallium melts in your palm like ice cream. Non-metals are the free spirits. Carbon, a solid. Bromine, a liquid. Oxygen and nitrogen, gases. Basically, they never stick to one dress code. Starting off with the second property, metals, they love the spotlight. Shiny, lustrous like gold, silver and copper. Non-metals usually look dull. Carbon is black. Sulfur is yellow and phosphorus is pale. But iodine shows up in a shiny purple, proving that even drama queens can sparkle like graphite and silicon. Starting off with the third property, malleability and ductility. Metals are the yoga masters. You can hammer them into sheets like gold foil or stretch them into wires. Copper wires, for example, but here are the rebellious exceptions. For example, zinc, mercury, sodium, potassium, gallium, calcium and lithium to make things difficult. And non-metals, snap. Sulfur and phosphorus, they break like cookies, exceptions. Zinc and tin are brittle metals, while graphite is a non-metal and can be layered into sheets. Now starting on with the fourth property, conductivity. Metals are literally the electricians of the world. For example, copper wire, aluminium pan, silver jewelry. Silver and copper are the best conductors of heat and electricity. Non-metals, they usually fail miserably at conducting heat and electricity, but graphite sneaks into the conductor slab with its free electrons. Now starting off with the fifth property, metals can handle heat. Iron melts at 1538 degrees Celsius. Basically, they are fireproof superheroes. Exception, mercury, gallium, cesium, sodium, potassium, zinc, lithium and tin. Non-metals melt easily. Sulfur at 115 degrees Celsius, phosphorus at 44 degrees Celsius. Exception. Diamond and graphite refuse to melt even at extreme heat. Starting off with the sixth property, sound, sonority. Metals love karaoke. Hit them and they ring like bells. For example, bronze and steel. Non-metals, silent types. Hit them and they just break. No music, only sadness. Now starting off with the seventh property, Density and strength. Metals are heavyweight. Iron builds bridges. Tungsten is super dense. Non-metals are lightweights. For example, oxygen and nitrogen float around like balloons. Exceptions. Sodium and potassium metals are so light that they float on water. Diamond is the hardest natural substance. So we are done here. So whenever you think of metals and non-metals, just imagine a classroom. Gym bros flexing, drama queens crying, and the class clowns breaking all the rules. Starting off with the second section of metals and non-metals, their chemical properties. Magnesium, the sparkler. Magnesium is a Diwali firecracker of metals. The moment it meets with oxygen, it bursts into dazzling white flame. Mg plus O2, you get MgO plus heat and dazzling white flame. When metals react with oxygen, they form metal oxide. For example, copper. It doesn't like fireworks. Instead, it slowly paints itself black like it's preparing for a rock concert. Cu plus O2, you get CuO, which is a black oxide. Aluminium is a superhero of metals. It instantly forms a protective oxide layer so that it shields it from the further attack. Al plus O2, you get Al2O3, which is aluminium oxide. Amphoteric oxides. The two-faced actors. Amphoteric oxides are the bilingual comedians that can talk to both acids and bases to give salt and water. For example, Al2O3, ZNO, PbO, SNO, etc. When metals react with acids, Al2O3 plus HCl, you get AlCl3 plus H2O. When metals react with bases, you get Al2O3 plus NaOH, you get NaAlO2 plus H2O. And this NaAlO2, it is called as sodium aluminate. Sodium and potassium, the hyper kids. Sodium and potassium are toddlers on a sugar rush. They react with oxygen vigorously because they lose electrons super easily. Because they have low ionization energy, so oxygen barely has to ask electrons. And when sodium and potassium react with oxygen, the hydrogen gas evolved catches fire. Note, H2 is a combustible substance. It does not support combustion. For example, Na plus O2, you get Na2O, and K plus O2, you get K2O. Anodizing aluminium is a smart metal. When exposed to air, it immediately forms a thin oxide layer of aluminium oxide. This layer protects aluminium from further corrosion, like natural shade. Aluminium basically says that I will handle oxygen myself. Anodizing is an artificial way of strengthening this protection in anodizing. In anodizing, a clean aluminium particle is placed in the electrolyzed dilute sulfuric acid. The electricity is passed through it, forming a thick oxide layer. This layer is a hard corrosion resistant and it can be easily dyed, giving aluminium an attractive decorative finish, like aluminium's skincare routine. Reactions with acid. Al plus HCl, you'll get AlCl3 plus H2. Al plus H3PO4, you get AlPO4 plus H2. Na plus HCl, you get NaCl plus H2. Mg plus HCl, you get MgCl2 plus H2. Zn plus HCl, you get ZnCl2 plus H2. Fe plus HCl, you get FeCl2 plus H2. Fe plus H2SO4, you get FeSO4 plus H2. Zn plus H2SO4, you get ZnSO4 plus H2. When it reacts with HCl, there's no reaction taken place. Okay. Now, moving on to metals when they react with acids. Nitric acid, HNO3, is that over-enthusiastic student in the lab who can't mind its own business. When a metal reacts with hydrogen gas, it is supposed to be released, but HNO3, it immediately oxidizes that hydrogen into water. And says, no bubbles today. Instead, nitric acid gets reduced and produces nitrogen oxides like NO2, NO, and N2O, or usually accompanied by brown fumes, which is NO. So, magnesium and manganese, however, manage to outsmart nitric acid, but only when it's very dilute. In that case, the acid is too weak and it's too slow. The reaction is so fast that the hydrogen gas it escapes before the nitric acid can interfere it. It's basically like hydrogen making a dramatic exit before the villain notices. Finally comes the aqua reaction. The reaction of Mg plus HNO3, you get MgNO3 whole twice plus H2. Mn plus HNO3, you get MnNO3 whole twice plus H2. Now we see Mn and Mg react with very dilute HNO3 to give hydrogen gas, which is very important. Now finally comes the aqua regia, a carefully dangerous mixture of concentrated HCl and HNO3 in the ratio of 3:1, where HCl is 3 and HNO3 is 1. And together they succeed where most of the reagents fail. HNO3 it initiates the attack by oxidizing the metal, while HCl it stabilizes in the solution. Even when noble metals like gold dissolves platinum and normally very resistant and also under these conditions. Moving on to the third section of NCERT, the reactivity series. Reaction with acid, hydrogen के ऊपर all these metals they react with acid to give H2 और displacement reaction. हमेशा ज़्यादा reactive metals कम reactive metals को displace करता है और H के नीचे these metals they do not react with acids to give H2. Memory trick. Top is the blast, middle is classic and bottom is dream or meaning no reaction. Now moving on to the fourth section of NCERT. Ionic compound. Ionic compound or formation is basically like chemistry in a proportion of dramatic makeover of one loses an electron, another becomes positively charged, another happily accepts and becomes negatively charged. Since opposite charges, they attract like best friends. Now moving on to the properties of ionic compound. Physical nature. And ionic compounds are solids and not hard because they work out, but because positively and negative ions are tightly packed in a rigid structure, and the strong force of attraction between these ions make them tough and stable. There's a mnemonic for this. Opposite charges matlab super tight. Now moving on to the next property, melting point and boiling point. These compounds have high melting point and high boiling point because breaking the strong inter-ionic attraction needs a lot of energy. In short, they don't meet easily. They are heat resistant champions. Strong bond is equals to strong heat. Now moving on to the next property, solubility. When it comes to solubility, ionic compounds love water but hate petrol, kerosene and oil. They dissolve in water because water helps these ions get separated, but they stay insoluble in non-polar solvents. And mnemonic for this, ionic loves water and hates fuel. Now moving on to the last property, conduction of electricity. Ionic compounds are shy in solid state and do not conduct electricity because the ions are locked in a space. In other words, there are no free ions present to conduct electricity. But molten or aqueous state ions become free and move towards the opposite electrons, and the electricity flows smoothly. Hence, they conduct electricity. Now moving on to extraction of metals. Occurrence of metals. Metals are introverts. They never roam around free. They hide inside minerals. When a mineral contains enough metals that we can earn money from, it becomes an ore. But ore arrives with unwanted bodyguards, for example, sand, soil. These are called as gangyo. Now there's a mnemonic for this. Ores is equal to opportunity to earn, and gangyo is equal to the garbage gang. So metals must go through extraction rounds depending on how reactive their attitude is. Low reactivity series, the lazy legends. Low reactive metals like mercury, silver, copper are so chill that they say, "बस heat दो हम खुद आ जाएंगे." Like HGS plus O2, while heating it you get HGO plus SO2, and HGO, while heating it you get Hg plus O2. Another example, copper does a smart trick called self-reduction. Cu2s plus O2, while heating you get Cu2O plus SO2. Now Cu2O plus Cu2s. Yes, it's taking its own ore for its reduction. That's why it's also called as self-reducing ore. You get 6Cu plus SO2. Mnemonic: low reactivity, matlab low effort, and only heating. Now moving on to middle reactivity series, the fitness freak. Metals like zinc, Fe, Pb are moderately active and usually founded as sulfide or carbonates. They first demand a makeover into oxides because metals are easier to extract from their oxides. Sulfide ore plus axis air, meaning roast. For example, ZnS plus O2, while heating you get ZnO plus SO2. Now we see carbonate ore plus limited air, you get calcination. For example, ZnCO3, while heating you get ZnO plus CO2, which is calcination, meaning limited air. Sulfide ore matlab roasting, and carbonate meaning calcination. Now we're moving on to reduction and thermite. Once oxides are formed, carbon can remove oxygen politely. ZnO plus C, you get Zn plus CO. Magnesium dioxide is heated with aluminium powder. MnO2 plus Al, you get Mn plus Al2O3 and lot of heat. But aluminium enters like a bodybuilder shouting move. This is thermite reaction, a highly exothermic displacement reaction. Fe2O3 plus Al, you get Fe plus Al2O3 and lot of heat. So much heat is produced that metals come out molten, and it is used to join railway tracks or cracked machine parts. Now moving on to top reactivity series, the drama queens. Metals like sodium, potassium, cesium, magnesium and aluminium are highly reactive. They cannot be extracted by heating or carbon reduction. Why? 3 things. First, more affinity for oxygen than carbon. Second, carbon reduction. Third, heating alone is useless, so the only solution is forcing them through electricity. The electrolytic refining. So electrolytic refining, we can imagine it as copper's spardium. For example, we will take copper. The impure copper is made the anode, the dirty dude. The pure copper is made the cathode, the clean queen. The electrolyte solution is made up of CuSO4 solution. Now what happens when electricity passes? The copper atoms at the anode lose electrons and they result as Cu2 plus ions. Then these ions travel through the electrolyte and at cathode and they gain electrons and they deposit as pure copper. And these impurities, they settle down at bottom of anode, are called as anode mud. Now moving on to the last section of NCERT, corrosion. Metals look strong, shiny, but the moment they meet, they start behaving like over-dramatic celebrities. Take silver for example. When new, it shines like it just won an award, but after some time in air, it turns black, as if it got cancelled on social media. This happens because silver reacts with sulfur present in the air to form silver sulfide, Ag2S, which creates a black coating called tarnish. Next comes the copper, the metals that clearly loves nature. Fresh copper is shiny brown, but after long exposure to moist air containing CO2, it slowly turns green, like it joined the eco-friendly club. This green coating is basic copper carbonate. Copper reacts with oxygen, CO2 and water to form this compound, Cu plus O2 plus H2O plus CO2. You get CuOH whole twice into CuCO3. And this reaction, this resultant is basic copper carbonate. Mnemonic for this is copper goes green. Now let's talk about irons, the most emotional metal of all. Iron cannot tolerate moisture. Just give it air, water and it starts crying in the form of rust, which is brown, flaky substance of Fe2O3. Rusting weakens the ions and makes it look like it aged 100 years overnight. The mnemonic for this is iron plus rain, you get pain. Now we look into the reaction. Fe plus moist air, you get Fe2O3 into XH2O. Iron clearly needs protection and humans step up like responsible parents. Rusting can be prevented by painting, oiling, greasing, chrome painting, galvanizing or alloying. But painting and alloying, which blocks air and moisture. But galvanizing protects iron by coating it with zinc, which sacrifices itself first. Now comes the funny part. Alloys, the superhero. Teams of metals. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal, made by melting and mixing them together and then cooling it at room temperature. Mnemonic. Alloy is equals to all together. Yes, if one of the metals is used mercury, then the alloy is known as amalgam. Few examples of alloy deserve a special fame. Now we will look into some examples of alloy. Brass, which is made up of copper plus zinc. Bronze, which is made up of copper plus tin. And solder. We'll look into solder. Solder is an alloy of lead and tin, has low melting point and it's used to join electrical wires. In conclusion, metals may look tough, but the air turns them into drama queens. Silver sulk. Copper goes green. Iron cries rust. And alloys come to rescue like superheroes. Chemistry isn't just about reactions. It's pure entertainment with equations. So that's it for metals and non-metals. I hope the properties are clear now. And more importantly, I hope you relate this topic not only to your studies, but also in the real world examples around you, like wires, utensils, aluminium foil, coal, sulfur, and maybe even materials we daily use. Now before you move ahead, take 2 minutes and revise the key differences: physical properties, chemical properties, and the most important, reactions. Because once these are clear, this chapter becomes one of the most scoring topics in class 10 science. If you found this video helpful, then don't forget to like this video, subscribe to Nexus QI and press the bell icon so that you don't miss any upcoming lectures. Also, comment below which property of metals and non-metals felt the most interesting to you. So that's it for today. See you in the next video with a new concept. Till then, keep learning, keep practicing, and stay connected with Nexus QI.